In this video, I'm going to be looking at the relationship between length, area, and volume of similar shapes. That is, shapes that have been scaled up in size, one to the other. And after we've found some of the rules involved, I'm going to look at a typical question that you might have to face on the topic. So let's have a go. As you can see on the right here, I've got a Rubik cube. And on the left, I've taken one of the elements of that cube out, and it's drawn separately here. I'm going to assume that the height of each single segment is 1 centimetre, the length 1 centimetre, and the depth 1 centimetre. This means that the area of the front face, the blue area here, will be 1 times 1, which is 1 centimetre squared, and the volume of the cube will be 1 times 1 times 1, 1 centimetre cubed. None of that will be surprising at all. Okay. Now let's put 3 cubes together along the bottom, these 3 here. The length of the bottom face will be 3 centimetres. And if now I stack that front face, another row on the top of 3 and another row on the top of that, the height of my resulting structure will be 3. So now the blue face will be 9 centimetres squared. Again, you won't be surprised to hear that if I now form the complete cube, the depth of the cube will be again 3 units, 3 centimetres, and the volume of the whole structure will be 27. It sort of means there are 27 of these single cubes in this whole structure. Now, none of those results will be at all surprising to you, but let's have a look at it now in terms of scale factors. Let's go back to the length. The length of our single unit was 1, and if 3 are put together, the length of the base of the whole cube is 3. So I can say that the length scale factor, going from the small to the large, each dimension is multiplied by 3. So again, looking at the front face, because the area of the new blue face has got 2 lengths involved, the area has gone up from 1 up to 9. So I can say that the area scale factor going from the left to the right, it means that any area on the left has to be multiplied by 9 to get to the area on the right. And similarly, because the volume involves 3 dimensions, all of which have gone up by a scale factor of 3, the volume has gone up by a scale factor of 27. Now, both the area and the volume scale factors can be related back to the length scale factor. The area scale factor is the length scale factor squared, and the volume scale factor is the length scale factor cubed. And that's quite an important result. It means that the length scale factor is the boss, because both the area and the volume scale factor relate back to the length scale factor. And this result doesn't have to only apply to regular shapes as we've got here. It can apply to any shape, so long as those shapes are a scaled version of each other. And the trick is, so long as you can get back to the length scale factor, you can work out anything about areas or volumes. Let's have a look at a typical question. So I've restated our results here that the area scale factor is the length scale factor squared and the volume scale factor is the length scale factor cubed. And we've got 2 similar shapes here. And we're told that the area of one of these faces is 16, and we're told that the similar area on the small unit is 4. 4 square units as opposed to 16 squared units. And the question asks us, find the volume of the large shape if the volume of the small shape is 525 cubic units. So the question is asking us about volumes, but all we know are areas. And as I hinted before, if we can go back to the length scale factor, we can work out everything about these 2 shapes. So let's have a go. Well, we're given the relationship between 2 areas. So as I scale up from the small shape to the large shape, the area of each of the faces goes up by a factor of 16 over 4. So I can say that the area scale factor going that way from small to large is 16 divided by 4, which is 4. So now we've found the area scale factor, we can go back and find the length scale factor by simply square rooting the area scale factor. So I can say, therefore, the length scale factor, LSF, must be equal to the square root of 4, which is equal to 2. Right, we now know the value of the most important thing, which is the length scale factor, and we now know it's 2. So therefore I can say that the volume scale factor is equal to the length scale factor cubed, which in this case will be 2 cubed, which will be equal to 8. So the volume scales up by a factor of 8. We're given the volume of the small shape, so the vol of large shape is equal to 8 times 525, which is equal to 4,200, and this will be cubic units. And that is your answer.